Okay, so the next few slides talk about how do we know it's actually greenhouse gases and not something else like the sun or volcanoes or something like that. So there's a bunch of different lines of evidence, some of which would perhaps be tough to understand without this class, but here's the first one. So this is looking at the wavelengths that are escaping from Earth and how that has changed over time. So this figure here is showing you 0, which is the sort of average amount of energy leaving at each wavelength between 1970 and 1996. And this is showing you the change over that period relative to the average. So a decrease then is saying that less energy is leaving from these wavelengths. If it were above that, it would be saying that more energy is leaving from these wavelengths. You'll notice, though, that there are no lines above 0. So all of our decreases all of our data are showing decreases at wavelengths. So the two big ones to really look at are first this dip right here, which is associated with that sort of 700 wavelength or wave number peak that CO2 does that funny bending motion at. So this is the decrease in energy because of adding CO2 to the atmosphere. So at the top of the atmosphere, we've got less of these wavelengths leaving. And then we've also got this sort of peak area here, or less energy leaving from these wavelengths due to methane. So this is some pretty strong evidence that less energy is leaving the Earth, and it's due to these increasing greenhouse gases in the atmosphere. And this figure is showing you sort of what the downward radiation is. So if you had a sensor on the ground looking up, what energy is getting radiated back down to the Earth. And this is then showing you that the radiation coming back down, yep, that's due to carbon dioxide, and then some ozone. This is nitrous oxide here, and then the methane. So this is sort of the reverse of the figure we just looked at. So another piece of sort of evidence here are day-night warming patterns. So you can think about this first. If the sun was sort of responsible for global warming, do you think that days or nights would be warming faster? So I would imagine you would think that perhaps it would be during the day when the sun is actually out, right? So, and nights might not be so affected. If it was global warming, we know that greenhouse gases, absorb and re-radiate infrared. So that's happening all, 24 hours a day. So that's happening in the daytime and the nighttime. And what we actually see is that nights are warming faster than days. So anything above 0 here means that there are more warm days or more warm nights than average, and less warm nights than average. And the same thing for days over here. So this would be more warm days than average, fewer warm days than average. The point here being that warm nights are increasing more quickly than warm days, which you would expect if it were greenhouse gases and not just the sun. So then finally, there are sort of these two pieces of evidence sort of go together, the fact that the troposphere is warming and the stratosphere is cooling. So why might this be happening? Because this is actually what is happening. And you can see that in this figure. This top figure here is showing warming over between 1997 and 2011, with the dark red being 0.5 degrees of warming per decade, and then anything blue would be cooling. But you can see the dominant trend here in the troposphere, the lower atmosphere, is warming, whereas in the stratosphere, you can see it's mostly cooling. So why might that be? So the troposphere, we've got greenhouse gases added in, so it's trapping heat. We're trapping heat in that troposphere, and that heat is no longer making it to the stratosphere. So the stratosphere is cooling off because it's no longer getting that energy that it used to be getting. So if we were in fact getting more warming from the sun or more energy from the sun, what might you expect that to look like? And I would think you would think that this is be more effective if we were actually in class together. That if it were coming from the sun, we know that especially the stratosphere gets warmed up from the top down, right? So it's got that ozone absorbing solar energy, so that might actually be getting warmer than the troposphere, warming more quickly. But in fact, we see the opposite, the pattern that you would expect if all of this warming was due to greenhouse gases. So in summary here, how do we know it's greenhouse gases? That the first thing being that escaping infrared is missing the wavelengths that greenhouse gases absorb. This implicates greenhouse gases. So the downward infrared getting radiated from the atmosphere to the ground is happening at the wavelengths that greenhouse gases re-emit at. So this also implicates greenhouse gases. We're also seeing nights warming faster than days, so this is implicating greenhouse gases, not the sun. If it was the sun, we might be seeing days warming faster than nights, you would expect. And then we see this warming troposphere and cooling stratosphere, which again implicates greenhouse gases, and in particular not the sun. All right, so the last bit that we're going to talk about is, are you not convinced? So what it's not, just a little more information about how we know it's not these other things that people like to talk about or like to point the finger at. And that'll be the next video.